Hi and welcome back. Today's video is going to show the manufacturing of the chassis parts that you saw me designing in the last video. Don't worry though, I haven't forgotten about the bodywork design and manufacturing. I'm going to take a step back and go through those as well in subsequent videos. So hope you enjoy the video. So this is where we got to on my last video, the completed chassis design. Today I'm going to take you through how I made some of the parts that are going to go into this chassis, and also unbox all the carbon parts that I ordered as part of my last video. The parts I'm going to show the manufacturing of in this video are the wheel adapter, the subframe, the chassis rail and the body mounting rail. I'm going to start by looking at the wheel adapter. So firstly, just a bit of a reminder of what it's actually for. So it connects the motor to the GT wheel that I'm going to be using. So one of the important features is this 17mm hex shape, because that's got to engage with the hex on the wheel. And also there's a couple of little holes that's not shown on the CAD model, but there's a couple of little holes on this motor face with some pins in. They engage in two holes on the wheel adapter to prevent it slipping around the shaft of the motor. So here's the design. So you can see the two holes that those pins go into on the back there, and hexagon shape, and this face that goes up to the inside of the wheel hex. So before I start making it, I needed to think about what's actually important on this. The most important thing is the hexagon shape, which has got to go into the wheel. So to get that, I decided to make it simple for myself by starting with hexagon shaped material. And I had to do a bit of research and source some aluminium hexagon bar from China actually, and get that imported so that I could make the part from aluminium. The next thing that's important is that these faces are parallel, so that means they're aligned to one another. So when I mount the wheel on and spin the wheel's going to sort of run true and not have a load of wobble to it. To get that, I'm going to have to be careful with the process I use to manufacture it. The position of these pinholes is also important, so I've got to manufacture that quite accurately to make sure that all this fits together. And also this shaft hole has got to be a tight fit onto the motor spindle. Obviously you wouldn't want that to be loose, because again then the wheel wouldn't be running true to the motor and it could cause some vibration issues. So as I mentioned, I'm going to make it easy for myself, use aluminium hexagon bar to make it from, and I'm going to use a lathe to make it. I'm going to show what I did to manufacture it next. When it came to the making I did using a lathe and a milling machine, I did that at this place called the Machine Shop in Hinckley. It's a place where you pay like a monthly fee to use their workshop facilities, which is fantastic when you don't need to use them all the time, or you need to use some specialist tools that are quite expensive and you don't really want to buy the tools themselves. Bob at the machine shop was really helpful in getting me set up on the lathe and milling machine, and he actually had to buy a digital readout for me to help me make my parts accurately, which he did, got it all set up, and that was much appreciated. So thanks Bob for that. Yep, on with the making then. So here we are with the lathe. The bit of hexagon material is already inserted into the chuck there. I took quite a bit of care over how I mounted that up to try and make sure it was as concentric as possible to the chuck. And what you can see there is the centre drilling. That doesn't take very long, so I'm quickly putting in the drill bit. Having said hello to the dog there. I drilled it to 5.5mm before then using a reamer to finish off the hole. The purpose of that is to get as accurate a hole size as possible. So this initial drilling generates quite a bit of swarf, as you can see there. So I get rid of that before installing the 6mm reamer bit that I used to finish off the hole. I was careful not to drill too deep into the material, because each time I made, when I went on to make the next adapter, I wanted to start from the sort of flat end of the hexagon bar again to the purpose of that was to try and keep the hole from wandering off over time. So that was the end of the drilling stage. This stage is the cutting the little shoulder on the end of the adapter. So I'm using like a normal turning cutting piece here, just gradually reducing the diameter of the end of the shaft there, and then every now and then checking it with the vernier to compare it with my drawing, to see if I'd got the correct dimension yet. So that's you can see the drawing there sitting on the end over the top of the lathe. This took a few goes really to get it down to the right diameter, and then after that I would check the depth that I'd machined that shoulder to. I think I was also using the digital readout that you can see at the top there to help me get that accurate. So I think once I'd done the depth, I didn't really need to touch it again because I'd done it off the digital readout. Yeah, that was all good then. So now I'm going to switch to the parting tool. So this is what is used to basically cut the piece you've just made off from the rest of the hexagon bar. And one of the ways I found of getting the part as accurate as possible was to treat this as my finishing cut on the part. So I was making sure I did the parting off to the correct length, so I didn't have to then do any more machining to finish off the part. This helped keep the two mounting faces parallel to one another that I mentioned earlier. So you've got to cut quite steadily and slowly with this tool because it's taking away a lot of material there, as you can see, and it's quite thin and spindly. It can get quite a bit of vibration on it. So this was just fed in by hand. This bit's sped up. But I've got a bit of welding wire there. You'll see why in a second. When it eventually comes off, you can sort of almost hear when it's going to happen because it starts. Yeah, there we go. It comes off, and that's not the finished part, but it's the end of the processes on the lathe. So after that, I'd mount it up into the milling machine, center it on the shaft hole in the middle, and then that allowed me to drill the two little location holes accurately. There you go, that's that part finished. On to the next one. The next part I'm going to show is the subframes. This is the front right hand side one. There's actually a different one on all four corners. The left hand front one is the mirror of this, but the rear ones have their own designs, and then one's obviously a mirror of the other one. So that made it a bit tricky to manufacture them, and a little bit of a headache, but I managed it by being quite careful. What they consist of is an aluminium U section, which has quite a few holes drilled in it, as you can see. These holes have got to be drilled accurately. That's really important for this part, especially in areas like this where these four holes are the pattern where the bolts go through and into the motor to hold the motor on. So if they're not accurate, then they won't go into the motor properly. Also, they've got to be accurate to the rest of the part. I mean, if they were too high or too low, it would actually raise or lower the ride height when I don't really want it to. These two holes here mount the brake system, so they've obviously got to be accurate relative to the motor holes. And the upper and lower holes are mainly for the suspension leaf springs. As you'll see, I'm going to be careful with how I drill those to make sure it's all accurate. And I'm looking forward to showing you how I get this outer shape to the right dimensions as well. I had a bit of a trick up my sleeve there for that stage. So yeah, let me show you. So the way I tackled making these four subframes was to do all the drilling of the holes in one go. So you can see my 1 meter long piece of aluminium C section there, bolted down to the bed of the milling machine. I could then take a reference off the end of that piece of material and then drill all the holes on one face, on the one face at a time. All the holes for, say, the front left, then I'd leave a bit of a gap, do the front right, a gap, rear left, and then a gap in the rear right. So this is where there was a lot of mental maths going on to try and not mess it up. I mean, you can see how complicated the drawing was there. This is where the digital readout that you can see at the top of the screen there was really useful. If it wasn't for that, I wouldn't have been able to use this method. I managed to do, I think I only made one mistake by 0.3 millimeters, so I think I did okay in it in the end. So I basically do all the holes on one face, rotate it around, reset it up, and then do the next face, and there's the 3 faces in total. The next stage was then to cut out those pieces and turn them into separate parts. So I'm going to show you the little trick I used to do that next. To help me cut out the subframes accurately, I made these templates. This was straightforward in Onshape, so in the same model as the subframe itself was designed, I could easily make these simple extruded shapes that I could then take out, 3D print, and then offer up to my bit of C-section with all these holes drilled in. So I'd use the holes to line it up and then just mark it out with a pen, because the outside of this didn't have to be machined particularly accurately. The holes were important, but the outside shape wasn't so important. And by doing it in 3 separate parts, I could actually use the same templates on the left subframe and the right subframe. So I had to make 6 of these little templates in total, 3 for the front, 3 for the back. Here are the actual parts that I used to mark out my subframes before I cut them out on the bandsaw at the machine shop. So you can see that one there, it's just been cut out, looks quite rough. And then after a lot of filing and finishing, I ended up with the 4 completed parts that you see there. As I mentioned, the last part I'm going to show the manufacturing of are these chassis rails. So these are all made from L-section aluminium extrusions. What you might notice is that they're largely symmetric, so you can see from this, the left and right hand ones, the holes are in the same places, so I could use that to my advantage as I made them. I'm going to show how I did that. Quite a few of the holes though I actually left till later on, when I could actually offer up the mating part, like for example these battery strap mounting holes on the top there. I waited till later on when I could actually use the part itself to mark up where these holes go. And also some of these ones down the side where it goes onto the chassis, I think I drilled the first one and then screwed it onto the chassis and then used the chassis itself to mark up the other ones, because that would give the most accurate result. That was particularly applicable for the body mounting rails. I think I used the method where I drilled one hole, marked up the other ones for those ones onto the chassis, but then the ones onto the body shell itself, I waited until I'd made the body shell, fitted it on, and then used that itself to mark up these 3 holes on each side. Right, I'm on to the next stage of the build, so I'm going to be drilling the holes I need in these aluminium sections that I bought. I bought these ready cut to length, and as accurately as I can measure them, they're the exact length that I asked for, so 430mm long they are. So don't need to do anything else other than just put all the holes in that are needed. I've got all those on a drawing to help me, and I've also 3D printed these guides, so these will locate on the edge, and then I can use that to center punch the holes before I drill them, which I find is quite an efficient way of setting the positions and accurate. So a bit of a top tip there. Let's see how it goes. So this is how I'm using the templates. I'm just locating it on that far edge there, right, lift it up till it touches the top, then put the center punch in there. 1 and 2. And the reason I haven't got a locating edge on that side as well is because I also want to use it at that end, so usable in 2 places. So yeah, that's how I use my little guide thing. So the first 2 holes are drilled. I drilled through both parts at once with the 2 parts clamped together with G-clamps, but now they're there, I could bolt them together. So now I can drill all these other holes that need to go through the same on both sides. So I might as well just drill them both in one go. So this is how I'm doing it. The beauty of a new drill bit. Today's unboxing, it's an exciting one. About a month ago I gave some designs to Rob at Yes Mate, and he organised for these carbon fibre parts to be made for me. So let's get into it. These have travelled a long way, so I'm going to be taking care to... what kind of tape is this? Some sort of tape that my knife won't go through. No, it is there. Right. I can see there's a sort of seam in this cardboard box there, so that's what I'm going for. Right, partly open. Right, this is going to be exciting. Wait till you see what's in this. Cut through my son's rear wing there. Oh. Well, it's a bit of a straggling bit there. All right, got the first layer off. It's like a bit like pass the parcel, isn't it? Ooh, exciting. Well packaged, as always. Wouldn't expect anything less from Rob. I can see the parts starting to become clear. Oh my goodness. That looks amazing. I better cut that. Wow. What have we got here? So well packaged, it's ridiculous. It would help if I actually use something sharp, wouldn't it? Oh, these body scissors might do a better job. I think that's all of it. They're all sort of sandwiched up together. This, I know this isn't it. This is a particularly cool piece, so let's have a look at how this came out. If I can ever get into it. Oh wow, these look great. I'm starting to feel quite staggered by how well that's come out. These are the battery straps for my car. These are what's going to hold in those 4 Onyx lipos, and I've branded it Yes Mate Stevenge. Wow, 3mm thick carbon. That is absolutely stunning. That is some serious quality there. So got a few of those there. I won't go through all of them. These are the springs, 4 of them. Let's get into that and have a look at one of those, because these are quite critical for my design. So my design works on a leaf spring principle, so these are actually what gives the car suspension. It's they're only 1mm thick, which means that they're a bit flexible, which is exactly how I planned it. God, they feel so flimsy and lightweight, but I'm sure that's still incredibly strong. The quality of that is amazing. So what have we got there? That's another 4 of those springs. And what's that there? Is that... oh, that must be my uprights. So I've got enough springs. Yeah, so these are the bulkheads, I think I've called them, or something like that. So these aren't particularly exciting, but a functional part nonetheless. These are what the springs react on. Oh, it's a bit like, this is like better than my Christmases usually are. I think no offence to my family and so on, but you know, this is Christmases all coming at once. Oh wow! I don't know what they've used to cut these out, but it's clearly incredibly accurate and gives lovely clean cuts. There's not even a fingerprint on that as well. It's amazing. So I've got a few of those to have some spares. Just get rid of this rubbish. And then we're on to the fins. So I've got 2 different sizes of fins. Give me some options to play with. Oh, come on. This stuff does not want to be cut. But I'm in. Oh, look at that. Beautiful. Oh, these are just stunning. Can you see that weave pattern? That's just beautiful. 1.5mm thick. That's all that's needed. I mean, it's so stiff. Just that extra 0.5mm over those 1mm springs just makes them a lot stiffer. And then I've got some taller versions of the part as well, so I can tune my aerodynamics a bit. Stunning. And then they're more tall fins. And then I'm on to the pièce de résistance, which is the whole chassis. You can probably tell that from the size of the thing. How am I going to get into that? Oh, there's some gaps here. They've left the protective film on it by the look of it, which is probably a good idea. This project has suddenly got real. I am already working on all the parts that are going to bolt to this. I was at the machine shop today, nearly all day, cutting up bits of metal for it. No, that's not going to do anything, is it? I'm just going to rip it off. Right, look at that. 700mm long roughly. All perfectly countersunk underneath where I need it. Bit of a what's it called? A combination of M3 and M4 there that I've used. This is the front, that's the rear. Wow, that is stunning. I can't wait to build this up. Okay, there we have it. So here's the chassis of my beast car, ready to be assembled. All I need to do now is make all the other bits, but I'm well on my way there. I've just had to get my video kit out again because I was just staggered by this. Across here it's supposed to be 140mm, so let's measure it and see what it is. 139.91, so it's accurate to within less than 0.1mm, and that could well be the accuracy of these verniers, so that's pretty awesome. Thanks for joining me for that video on the manufacturing of my chassis parts. I'm really excited to share with you the journey I went on with the body side of the project in my next couple of videos. The first one's going to go through the design stage and the CFD, and the second one is going to go into the manufacturing like we've just done with this video. So thanks again for watching, and thanks to Rob for your generous sponsorship and in providing those carbon parts for the build. And I'll see you in the next one.